Good evening, students. Welcome to Maid Academy. I hope all of you are doing well and are safe. My name is Veena Menon, and I'll be teaching you physics for the 11th grade.
So let us begin our journey with the first chapter, physical world. When it comes to exam point of view, that is exams conducted in your schools or other competitive exams like JW or NEET, this chapter may not be of that importance. But overall, this chapter is very, very interesting because it gives an idea and some interesting facts about physics. So let's get started. Okay, so when it comes to science, as in, one should always ask these WH questions like, which is why, what, where, because it is these words that actually brings amazing discoveries in the world of science. So a tip: never hesitate to ask questions. Okay, always ask questions and be curious. So on the screen right now, the first question that you can see is written, what is physics? Okay. Now, if you look at the word physics, it is definitely an English word. Physics is written in English, but it is actually derived from Greek word called physis, okay, which means nature. Now, why nature? Okay, so if you look around you, you might have seen different natural phenomena like sunrise, sunset, day, night, different celestial objects in the sky, and sea waves, etc., etc. Even right now, you can hear me speak. The reason why you can hear me speak is also due to physics. The reason why you can see the screen, there are different colors on the screen that you can perceive, is also because of physics. Okay. So we human beings are very gifted. Okay, we have different abilities that has been gifted to us, and one major ability that makes us different from any other living beings, or that makes us superior to any other living beings on this planet, is the ability to think. Okay, so we human beings are very curious. We have always asked questions. It is always said that the nature has all the solutions. It always has all the answers to all our questions. So if you just ask question, the nature will give us the answers. So that is the reason why we say physics is nature, because whatever laws is happening, whatever natural phenomena is happening, it's all because we have asked questions to it, and the nature has given us answers. And one interesting fact is that when you write this fuses, when it is written in Greek, it actually looks like this. And all these symbols are actually used in physics to denote some values or some form. It is always used in sort of some formulas you will see later ahead. So this is one of the interesting fact, that all the letters in these are used for notations. Okay. So as I've told before, that physics is nature. So what about science then? Science is also nature. What about other branches of science like chemistry? There is biology. Biology is also related to nature. What about that? Okay, so science as a whole is definitely an effort to understand what is going on, like natural phenomena. It is to predict and modify. Okay, it is to explore. Science is exploring, experimenting, then you predict different things from what we see around. We are always curious. This curiosity is necessary to learn what is going around the world, and just to unlock all the secrets of the nature. And being curious is the first step towards science. Okay, so physics is only the study of basic laws of nature. So science has different branches. Okay, it has chemistry. We have divided science into different branches only for our convenience, and from them, physics is just a study of basic laws of nature. So I hope there's no confusion, right? why not science is nature? Science is also nature, physics is also nature. Okay. So now, as I've mentioned, that physics is a study of basic laws of nature, right? Now, what about these laws? Like, how do someone makes these laws? Okay. Do just because we know that sun rises from the east and sets in the west. So somebody in the past told us that sun is rising from the east and setting on the west. So it is like that only. No, somebody there might have done they might have done some kind of experiments to prove it, right? So there is certain methods to form a law. You cannot just declare anything. Okay. I'll explain. There are certain methods. I'll explain you with the help of an example. So, for example, just imagine that we are living in a very old age, like maybe in the 1800s or something like that, where there is no technology or science, not much of development, where science has not been developed much. Okay, so I am observing a cat. Okay, and I come to know I observe a cat every day, and as I said, that laws are always we need to ask questions to the nature, right? So I have been observing a cat, and I find that the cat is sleeping, eating food, walking, etc., etc., and then suddenly I saw that the cat is jumping from one building to other, but it doesn't. It falls. It always falls. When a cat jumps, it always lands on their feet. So what I find one day is that no matter at what height the cat jumps from, it will always land on the feet. Okay. So this is an amazing discovery that I found. Okay. So I go and tell to other 10 people around me that see so and so is a thing that I've observed, that no matter a cat will always land on their feet irrespective of the height. Okay, so now those 10 people won't believe me because they have never observed it. They have never seen a cat doing this. So they think that I'm just bluffing. So they ask for proof. So what I need to do is that I take all those 10 people to a place and then I drop a cat from a building. I take a cat to one story building and then I drop it. And then some people note some observations. Again, I do the same thing, but with another building of a different height, maybe two-story building, that is a building that has two floors on it. And then I drop a cat. And then the people observe some things. Again, I do the same thing in the three-story building, four-story building. And this, I'll continue this experiment until and unless the other people don't start believing that, yeah, she has said is correct. Whatever, that the cat will always land on the feet, irrespective of the height. So, what did I do? I conducted multiple experiments, same experiments again and again. And in all the experiments, one thing common should be that whatever whatever law I stated should be correct. Okay, no matter how the experiment was conducted. Okay, so these are the methods that you need to follow while making a law. Okay, one is observations. For example, in my case, I observed a cat. I observed a cat for a very long period of time, and then the next method is controlled experiments. So I performed experiments on cat just to prove the law. Then I'll explain the other one, that is qualitative and quantitative reasoning. Other is mathematical modeling, that maybe I can derive some equations using just to prove that law, just to support that law. Then I can predict. Suppose I just did this only till 10 stories building. But why I stopped at 10 stories building? Because I know no, even after that, even if it is a 20-story building or a 30-story building, the cat will behave the same way. Okay, so I can predict. Now the last one is verification or falsification of theories. Okay, if somebody had if before stating this law, if somebody else had stated any other law, I could prove it wrong by stating this is the law. Okay, So this was just an example how a law is formed, okay? But these are the methods that whatever laws you see around, whatever laws you study, these are the experiments, these are the methods that scientists or people all over the world follow. That is, in you need proper observations, need to conduct experiments. Qualitative and quantitative reasoning is that qualitative means it is non-numerical descriptions, like qualitative reasoning means you use some like programming or where there is no need of any mathematical equations. For example, yeah. So qualitative reasoning is using methods that does not have any numerical descriptions or any mathematical equations to prove a law. You can use there are there are AI technologies right now that is completely based on programming. Okay, so for example, I won't go into much discussion about qualitative and quantitative reasoning because that is not necessary. But I'll just explain just to understand. I'll give you an example that's just to explain what the thing is. For example, there are instruments that can actually observe the level of river water, water level of the rivers, so that we can know beforehand whether it is going to flood, whether the area is going to be flooding or not. So there are certain instruments. So that is qualitative reasoning. Quantitative reasoning is using mathematical modelings, using diagrams to explain the law. The other one is mathematical law modeling, where you use derivations or certain numerical expressions. Prediction is again you can predict this law for all the other things as well. And verification or falsification of theories. One example that I would like to tell you is that in the olden days, people used to believe that Earth was the center of the universe, but then later Galileo proved no, it was the sun that was at the center, and all the planets revolve around sun, not on Earth, not around the earth. So that is verification and falsification of theories. So these are the methods that is followed to make a law. Again, so there is no final theory in science and no unquestioned authority in science. So whatever you study, it's not final actually. Because tomorrow, you know the Newton's laws of motion, right? So if tomorrow, if you come up with some better laws that can prove wrong, that where you can prove that Newton's laws are not working, then that again, so your laws would be taken into consideration. So again, there is no final theory in science or no unquestioned authority in science. Physics has two principal goals, okay? The laws in physics has two principal thrusts. Thrust means goals. One of them is unification. That means explaining different phenomena using one law. Okay, there are different phenomena around the world. So there are you can explain certain phenomena using just one law. For example, the apple falling on the earth and the moon revolving around the earth, as both of them are governed by the same law. That is the law of gravitation. Okay. So if you look at this, the apple falling on the ground, the size of apple is very small compared to the moon revolving around the earth. No matter what the size is, but the laws governed is the same, that is law of gravitation. So this is called unification. Another is reductionism. That is, to understand a very big system, you cut it into smaller parts, and you just have to understand these small part just to know what is going on in the whole system. For example, if you want to know why that cup of tea is hot, you need to get in depth of the tea, that is get into the smallest level, that is the atomic size level, and understand what is going on inside the atoms between atoms, electrons, and nucleus to understand why the cup of tea is hot. So this is called reductionism. Okay, so this is the end of part one. In the next part, we'll discuss more about the scope of physics and different branches of physics.